Welcome to Wisp World, the place where new and existing wireless internet providers gather to learn about the latest things happening in their field.
Hey everybody, I was just working on a Wisp World podcast there. You can find out more about the Wisp World podcast at laminarwireless.com. It's been a while, but I did promise everybody I would do a demo video on how I automated my house using the mFi system from Ubiquiti Networks. Now I do have to warn you, the video is not going to quite be as exciting as the trailer was. As is often the case when you have a theatrical trailer, there was more excitement there. However, what you will learn over the next few minutes is the problems that I've encountered, the solutions I've found, and some of the neat things that I've been able to do that maybe you can do at your house or your business. So without further ado, let's go on a quick tour of mFi here at the house. So we'll start here at what I like to call the climate control system. We've got the old Honeywell thermostat in here, which controls the heating system manually if you want to do an override. Otherwise, the oil furnace here in our house is controlled by the mFi system, and actually just turned off, so I'll have to turn it back on, which I can do in a moment here. But the way it works is there's an mFi temperature sensor, and that runs down here to a bunch of M ports. Now, if we could get more than a 3-port M port, that would solve this whole problem here where I have a whole mess of wires and multiple M ports. But unfortunately, we only have 3 to work with at the time being. So here's what we've got. Over on this M port, we have a temperature sensor, the temperature sensor that's up on the wall, and then we have an input and an output and a ground wire going down here to this 4-relay device. The 4-relay device, when it gets a 12-volt power output from the mFi M port, it closes the relay on this side. And when that relay closes, these blue wires here go all the way up the wall here, and they connect into the thermostat here. So basically, when the mFi server detects the temperature in the house is within a certain range or outside of a certain range via the temperature sensor, the M port down here closes the relay, which starts the furnace, and then also vice versa, it turns it off. Then over on this M port here, we have a motion sensor that's located up here on the ceiling, and that motion sensor does several things. If we're away from the house for a while, that motion sensor will send a text message if there's motion in the house, because there shouldn't be. Also, it senses motion in the living room to turn on night lights at night. So if there's motion in the living room, we have wired here to the output some LED lights. So those lights illuminate a little light here that shines into the living room very non-intrusively. And then there's also a wire that goes into the bathroom, and there's a little white LED in there. So if you get up at night to go to the bathroom, the lights automatically turn on a very nice low light LED so that you can see your way, but it doesn't blind you. And then we also have over here connected to this M port, again because we're trying to use ports as efficiently as we can because we only have 3 ports and the M ports are $80 a piece, so we don't want to waste them. We also have a small piezo speaker. Now the piezo speaker is connected to the second output here and is purely a 12-volt output, but that is used for signaling for time-sensitive alarms. So we have an alarm code up here on the wall, and if I could get Linker to give us the ability to pulse outputs on the M ports, this wouldn't be quite as much of an issue, but as it stands right now, we don't have the ability to pulse outputs, so I have to go with time-based alarming. So if we have a non-stop alarm, that means the furnace duct or flue is over temperature. Very critical alarm, so it's just going to sound and keep going off. A 30-second alarm, that means our deep freezer, the temperature in there has gone above where it should be. A 10-second alarm, there's been an intrusion in the garage on the perimeter, and a 5-second alarm, there's a garage intrusion, a motion sensor has been triggered. And we'll show you those things in a moment here. So that's basically the temperature setup. My plans for this summer are to put a little push button over here, which will connect to the one available port on the M port there. And then our house does not have air conditioning, so my plan is to, but it has a whole house fan, so my plan is to put an M-Power upstairs connected to the fan, so you can push a button, start the fan, and then when the fan has either run for a certain amount of time or it's past 11 p.m. because everybody's in sleep, it's going to shut down, or when the temperature differential between inside and outside is greater than a certain amount, it will shut down as well. So that's how we've automated the temperature control in the house, as well as the motion alarming and some night lights here. Alright, and then here we have an mPower this mPower is connected to a little Coleman night light, but rather than burning it all night long, that is also wired into the motion sensor in the living room. So if there's motion in the living room, that turns on. That also used to turn on when the garage motion sensor came on, so that, say if you were coming home at night, you could come upstairs and there'd be enough light in here that you could see. There's also a water cooler wired in here. We don't use the water cooler all that often, but it's set up that on Sunday mornings, when I like to get a warm cup of tea or coffee, it turns on, and that way I can get just my warm cup of tea. Normally I drink it at work, but on Sunday mornings I drink it here at home. So that way, cooler's on, but I'm not wasting electricity the rest of the week cooling water or heating water that doesn't need to be cooled or heated. So again, here as we move to the basement, I'm going to show you this temperature sensor, which is located outside oh hey, look, there's an air cam. Is located outside underneath a shielded roof, but it is located out here. And this is again because there's only 3-port M ports, so we are trying to use those ports as effectively as possible. This is the outdoor temperature and humidity sensor, and this runs to an M port that's in the basement, so that we can monitor outdoor temperature. And it works really well down to 15 degrees. Once you hit 15 degrees, it plateaus, because that's as low as it goes, but that's good enough for everything that I'm concerned about. Here we've got an RTD temperature sensor that goes here to the freezer. It's just a big RTD probe that hangs down into the freezer, so that way we can keep an eye on the freezer temperature. And if it goes above a certain temperature, I think it's set to 15 degrees Fahrenheit because it's a deep freezer, it does alarm. So that's connected right to the RTD terminals there on the M port. And then we also have the outdoor temperature sensor connected here, and then something a little different. We've got a wire running over here to the doorbell transformer. And on the doorbell transformer there's an mFi current sensor. So if the doorbell is rung, it sends a text message and an email. Sometimes UPS will deliver things and they ring the doorbell, nobody's home, that way you know that something has occurred. You can also log into the AirVision system, if you've got one, and see who's there. Haven't quite gotten to the point where we can talk back and forth to the person, but that might be forthcoming at some point as well. Just call a phone number and it opens an intercom. Alright, then here we are on the second part of the heating system. We've got the M port downstairs here by the furnace. It's a large furnace made by a Canadian company. I forget what the name of the company is off the top of my head, something Matic, but it's a dual oil and wood-fired furnace, and so we can only control the oil, obviously, for now, although perhaps we can control the dampers and things like that for the wood eventually. So what we have here right now is an RTD temperature probe going into the duct. That allows us to monitor duct temperature to make sure that it is not over 200 degrees. If it is, we shut down the oil. If the wood is burning and the duct temperature goes over 200 degrees, we sound the alarm upstairs so that there's human intervention that can take place to avoid a chimney fire. There are future plans to stick a duct into the actual flue so that we can monitor flue temperatures and proactively stop a flue fire from occurring, but that's not in place yet. And then also over here we have a wire running over to a door sensor. The door sensor is located on a blue door here that goes outside. That way, if for some reason there's an intrusion that takes place, the door is broken, that will alarm, and at night, based on certain temperature or certain time schedules, that sends emails and sounds alarms and things like that in the house. Okay, then out here in the garage, you're going to have to use your imagination right now because this M port is down for repair. It got moved somewhere else where it was needed. But the way this had worked is there was a motion sensor located up here on the roof of the garage, which is interesting because when I first put it in I was getting a lot of false alarms and I thought it was the mFi system maybe, but it turned out that it was actually rodents in the garage that I didn't realize I had. So we set some rat traps and those have since been taken care of. So anyway, up here we had an M port, which is missing at the moment, and another relay board. And that relay board is then connected to the garage door opener switch. Here it's wired in line, so that when that relay triggers, the garage door will open and close just as if you were pushing the button there on the wall. And so what would happen is, during a very small window of time, like say 7:30 to 7:45 in the morning, if there was motion detected in the garage, because I was walking in around that time, the door would open, it would stay open for a minute and a half. If no motion was detected at that point, it would close the door. And so basically the morning routine was pretty much automated leaving the garage. There was a door sensor located outside the garage door, which would detect if the door was open or closed, so we made sure the door got into the right position. Unfortunately, what happened there also is that the garage door spring broke, the door came off its hinge, and the door sensor broke on the door. So this section is down for repair at the moment. And so then, finally, the brains of the operation. Here we have a tough switch, a 5-port tough switch powering things, and we have a trend net switch kind of doing some interconnect, and a compact laptop that basically runs everything that needs to be run here. This runs the AirVision system at the house, as well as the mFi system, and it's been doing a really good job at it. So that's a look at how we've automated the house with mFi. There's been some downfalls, a few little issues with sensors and with timing, all things that Ubiquity's worked through and resolved when it's been a real issue, which is one of the things I like about Ubiquity. But overall, it's worked out really well. The house, for the most part, is pretty good. The wife's happy, so it all pretty much passes the wife test, which is always a plus. And speaking of all that, we have a new baby that's supposed to be here around the end of April. And since I'm planning to put some mFi equipment in the attic to turn on and off the fan, and I need a door sensor up there so I can sense if the door to the attic is open or not, so I don't start the attic fan while the door is closed, because that would create a suction problem, that means I'll have a few extra ports to play with. And the attic steps are right beside the baby's room. So I started thinking, what can I do with those extra ports? Well, for one, I can run a temperature sensor into the baby's room. That way I can proactively be notified if the temperature in the baby's room gets too hot or too cold, and we can make changes. Manually to start, but perhaps automatically later on. Automatically starting a small space heater or an air conditioner to regulate the temperature. But then I thought, why stop there? Certainly there's moisture sensors and sound sensors that can be hooked up to the terminal block of the M port. So why not run a moisture sensor from the terminal block to the baby's diaper? That way, if the baby wets itself during a nap, we can be proactive about changing the diaper, not waiting until the child cries. I'm all about proactive. That's how I run my network at work, trying to fix problems before customers even notice. And so why would I do it any different with my child? Additionally, there are sound sensors, and I'm sure with some creative programming, I can set it up so that I can figure out what that cry means. Is the child hungry, or are they wet, or are they tired? And depending on what kind of cry the mFi system detects, it can do things. For instance, if the child is hungry, it can start warming that bottle of milk that's in the microwave, or grinding some food. If the child's wet, it can send me a text message to change the diaper. And if the child's just cold, why, it could turn on the heat, or start rocking the crib back and forth with an automated relay. Why, what I can do with mFi and my child are limitless. Perhaps we'll make another video at some point. Hey, thanks for watching. Hope you've learned a little bit about what you can do with mFi, what I've done here, and if you have any questions, feel free to send me a private message in the Ubiquity forums. My username is mHoppus. Look forward to speaking with you more there. Thanks so much.